Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about anything I want to, science and math related. And today we are doing a chemistry talk on acids and bases. It's chapter 19 in this book. And but you don't have to be going through this book to learn this. But if you are, I think this is going to be our last video. I should have been wearing the party hat. I always wear the party hat for the last video. I might do 20. So maybe I'll do 20 as a separate one. I was going to combine 20 in with this one, acids, bases, and neutralizations. I'll do a little one for 20 and then I can wear the party hat. All right, strike that. This is going to be the next to the last video. There's more to the book, but we are going to end it because what is left is more Chem 2, AP Chem, and in college chemistry. Now, but what if you want to learn these things? What you need to do is you need to go, you're going to have to switch from me. You need to go to Peterson Science. With a D, not Peterson, Peterson Science. It is a teacher in the county I teach in, and he has videos that are for AP and honors chemistry that will cover all these topics, and they're really good. So watch his videos. They're short. He explains every bit of this very well, and he would explain the rest of your book for you. So I'm going to just let you go to him. But those of you who just want regular chemistry, we're going to be done with acids and bases. We're not going to go into redox and the more complicated stuff. All right, and this should be finishing in mid-May, and that's the right time to finish, right? Mid to late May. So good, because we're doing 2 weeks per chapter, and we will have done a whole year of chemistry. So well done. All right, so we're going to end in something very interesting. Acids, bases, and neutralizations, those go together. And it's something you already know a lot about. You know about acids. You've tasted a tomato and go, oh, that one's too acidy for me. You know what an acid is. So let's talk about it. And the interesting thing about acids and bases is historically we have known what they are, but then we've had to kind of catch up and figure out a definition of it chemically. I'm looking for my water in case you're wondering here. All right, there it is. There's my water. So we're going to learn a bunch of different definitions because different chemists have come along and made different definitions. It's something we knew what it was before we knew how to define it chemically. So what is an acid? Acids taste sour. Acids conduct electricity. Acids feel like water. So you can think of like vinegar. Vinegar feels like water and tastes sour. And if you put a probe in it, it conducts electricity. So those are some things about it. It also will cause indicators to change colors like litmus. If you have blue litmus paper and you put acid on it, it'll turn what's called red. It's really pink, but we'll call it red. Also, there are other indicators. You're going to use one in lab this week where you're going to make your own indicator with, they call it red cabbage or purple cabbage. You know those cabbages, they're usually a little bit smaller and they're kind of purpley looking. You buy them at the grocery store. You're going to buy that, shred it up, cook it, and it makes all this red juice come out. That red juice changes colors, whether it's with an acid or base. It's very fun. If you want to, you can also go to a place like School Box, someplace that sells educational stuff, and you can also buy some litmus paper and use that also. You can buy the litmus paper also if you have a homeschool convention near your house. We have one every year. We have a bunch of them here in the Atlanta area, but there's one over in Cobb County at Galleria Mall, and they always sell some of the science equipment like the litmus paper, and if not, you can always order things off of homesciencetools.com. They would have, you can buy a universal indicator, which is a lot of fun. Phenolphthalein is another one that's fun. And hydrion papers are fun. Blue and red litmus, all of those are very fun to learn about indicators. So acids will make indicators turn colors. So that's an acid. Well, what's a base? What's the opposite of an acid? Bases feel slippery. So these are soaps and cleaners. This is ammonia. This is shampoo. This is soaps. It's also lye, sodium hydroxide. There are other bases. Hair dye is one. Drano is another one. All of those are strong bases. They feel slippery. They turn blue litmus. They turn litmus blue, so they turn red litmus blue, and you can remember that because base and blue both start with the letter B. They also conduct electricity. So kids always say, I say, which is dangerous? And they say acids, and the truth is both. If weak acids are not dangerous. Vinegar, not dangerous. You're not scared of your pickle. Oh no, a pickle. It is the strong acids like hydrochloric, nitric acid. Those are the strong ones that are dangerous. Strong bases are also dangerous. Weak bases are not dangerous. Baking soda is a weak base. You don't worry about baking soda. Oh, I'm putting baking soda in my cake. I'm going to die. No, you're not. So weak bases are not dangerous. Weak acids like coffee, tea, Coca-Cola, not vinegar, not dangerous. But as you get stronger on both ends. Now, what happens if you mix them together? And that's what we're going to do one more video on, I think, neutralizations. I always say, what happens if you mix a strong acid like hydrochloric and a strong base like sodium hydroxide? What do you get? And kids always say, an explosion. No, you don't. You get a neutralization. They cancel each other out. And in particular, you can get salt and water, salt water, just as boring as you can get, right? Now, there are more things that are called salts in chemistry than table salt. So it might be a different salt, but it's a chemical salt. Salt water is what you get if you add them together. Let's see what we want to say. Now, how do you name acids? Acids, or if it has, if it's just a regular acid where it is bound to an element, not a polyatomic element, just a single element, then it is, how you name it is you say hydro, then the root of the element it's bound to, and then ic acid. So it's hydrochloric acid because it's hydrogen and chlorine bound together. Okay, so hydrobromic acid, hydrofluoric acid. All of those, you say hydro, the base of the elements the hydrogen is bound to, and then ic acid. It gets more confusing if it's bound to a polyatomic ion. And you can, if it is bound to something that ends in ite, then you add us acid, so it's called like sulfurous acid. If it is bound to a polyatomic ion that ends in ate, then you change the ending to ic. So the nitrate polyatomic ion makes nitric acid. Now, I know that sounds a little confusing, but I'm going to tell you something to make it easier. If the polyatomic ends in ate, then it will end in ic. Your acid will end in ic. So you have ate, ic. How you remember this is if on accident you ate dog poop, you would say ick. So the key is dog poop. If you ate dog poop, you'd say ick. So any polyatomic ion that ends in ate that is in the acid, the name will be the root plus ick. So hydrogen plus the polyatomic ion nitrate makes nitric acid. All right, see, that's not so hard. Mark Peterson has another video on this you can watch, but he laughs, but he never says dog poop. He didn't want it on video, him saying dog poop, but I said dog poop. Also, there are more videos on this on my other YouTube playlist, Elements of Chemistry. I have a whole nother video on acids and bases. You might want to go watch that one too. If this one just doesn't do it for you, you can try the other one. But I talk about the dog poop in that too. All right, so bases, they produce OH, just like the acids have hydrogens, bases have OHs in them. And so with a base, it is the name of the positive part, the cation, followed by the name of the anion. So like one common base is Li, sodium hydroxide. Sodium is the cation, the first part of it. And then the last part, OH, is the polyatomic hydroxide ion. So it's just sodium hydroxide. So for the bases, it's really, you're just naming it the regular way. All right, so